Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's natural sciences lesson. My name is Siada Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we're still on our term 2 and still exploring the knowledge area matter and materials, which on today's topic we're going to talk about the pH value, right? Today we're going to talk about the pH value and more specifically on the concept of the pH value. Right. So now let's quickly look at our lesson objectives, right? This is what we need to achieve by the end of this lesson. So when this lesson ends, we should be able to firstly define the pH scale, right? We should be able to define the pH scale. Not only that, we should be able to compare and contrast acids and bases using the pH scale, right? We should be able to look at the similarities and differences of acids and bases using what? The pH scale. Also, we need to be able to analyze the pH scale, right? And that's all for today's lesson in terms of its focus. Right. So all this information is found under the CAPS document on page 67, right? So let's quickly look at our pre-knowledge now. So remember that in grade 7, we introduced the topic of the periodic table of elements, right? We talked of the periodic table of elements, and here is a picture of a periodic table, right? We said that the periodic table has about 118 known elements so far, right? Or that have been discovered so far. Are we together? Also, in grade 7, we also talked about acids and bases, right? We introduced the topic of acids and bases as well in grade 7. Then later on in grade 8, we talked about atoms, right? We said that atoms are building blocks of matter, right? And matter is anything and everything that occupies space and has mass. So also on these atoms, we said that these atoms are made up by subatomic particles such as the positively charged protons, the neutrally charged neutrons, and the negatively charged electrons, right? So also in grade 9, we talked about compounds and chemical reactions, right, in the past lessons. Also, we talked about acids and bases in the very same grade that we're in now. And today we're focusing on the concept of the pH value. Right. Now, before we go further, let us look at this baseline activity. I'm going to give you some time to write down your answers, but firstly, let's go through the questions together. Number 1, write down the formulae for number 1A, two metal hydroxides derived from group 1 elements of the periodic table. Two metal hydroxides derived from group 2 elements of the periodic table. Then number 2, consider the following reaction, right? The reaction is sodium plus water to form sodium hydroxide plus hydrogen, right? So it is 2Na plus 2H2O to form 2NaOH plus H2, right? So you simply have to name the compounds in this equation. Then number 3, right? Write down what the products that are formed during the neutralization reaction. Right. So I'm going to give you 5 minutes to copy down and complete this activity. Then after that, we shall meet and mark together. Welcome back, grade 9s. Now remember, if you want to send in your answers for us to check them, your comments or any questions regarding this lesson, our WhatsApp number is 079 578 2908. Right, so let's look at the solutions together now. Right, number 1, Roman figure 1. Two metal hydroxides derived from group 1 elements of the periodic table, right? And this is the whole list of what? Metal hydroxides derived from group 1 elements of the periodic table, right? So we have lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, calcium hydroxide, and so on, right? So, but you can choose any two that you have written amongst these, right? Because we only require 2 from you. Then Roman figure 2, two metal hydroxides derived from group 2 elements of the periodic table, right? And these are the answers, right? Beryllium hydroxide, magnesium hydroxide, calcium hydroxide, and the list goes on, right? So you can only mark the first 2 or any 2 that you have written amongst these. Right. Now consider the following reaction. 2Na plus 2H2O to form 2NaOH plus H2, right? That is sodium plus water to form sodium hydroxide and hydrogen, right? So name the compounds in this equation, right? Name the compounds in this equation. So remember, compound is what? 2 or more different elements that are chemically bonded in a fixed ratio, right? So now, what are the compounds in our equation, right? The compounds here are water and sodium hydroxide, right? It is water and sodium hydroxide. Right, number 3, the products that are formed during the neutralization reaction, right? And those products are salt and water, right? We know that during a neutralization reaction, we form products such as a salt and water, right? So let me give you a quick 2 minutes to copy down the corrections. Then after that, we shall sail through together with our ship. Welcome back again, grade 9. I hope you had enough time to copy down the corrections, right? So now let's move on together and starting off with the important terms that you're going to come across during this lesson. The first term that we have there is acids, right? We define acids as substances with a pH of between 0 and 7, right? Between 0 and 7. Those are our acids. Then we have bases, right? And bases are substances with a pH of between 7 and 14, right? Between 7 and 14. Then we have alkali, right? Alkali is a synonym for base, right? So these are bases that can dissolve in water. Right. We also have pH value, right? And pH value now is the number between 0 and 14, right? That number between 0 and 14, it tells us how acidic or basic a water-soluble substance is, right? So it tells us how acidic or basic a water-soluble substance is, and it ranges from 0 to 14. That is our pH value. We also have neutral. Neutral now are substances that are not acidic nor basic, right? And they have a pH value of 7. Then we have indicator, which is a dye that has different colors in acids and bases, right? It is a specific dye that gives us different colors for acids and bases, right? That's all for our terminology, and let's get on to today's main meal. So what is pH value, right? What is this pH value? As we just said now, the pH value is the number that tells us how acidic or basic a water-soluble substance is, right? And that number, it is a scale that ranges from 0 to 14, right? Showing us different levels of acidity and different levels of alkalinity, right? All the way from 0 to 14. Are we together? So now, here is an illustration of a pH value, right? We have what? Numbers and different colors ranging from 0 all the way to 14, right? If you can notice now, right? At the ends of this scale, right? This is where we find our strongest and darkest colors, right? They are strongest because this is where we find most of what? The strongest solutions, right? In terms of alkalinity and acidity. Are we together? So now, let's move on, right? So now, some of our foods make our tongue curl up because they are sour, right? And we mentioned foods such as lemons and pickles, right? So these foods, they have different tastes, right? Some of them, they make our tongue curl up because they are sour, right? So if you think of a lemon or pickles, right? When you eat these lemons, your tongue curls up, even your facial expression changes, right? Because the taste of the food is sour. But some foods, they have a bite of their own, right? Because they are somewhat bitter, right? They are bitter and not what? Sour. They are the opposite of sour. They are bitter. Are we together? But the question now is why? Why do we have sour foods? Why do we have bitter or sweet tasting food, right? Which is what we are going to explore today. Are we together? So now there is a scientific reason for this, for us having what? Bitter food and sour food. This is because what? The foods now can either be acidic or basic, right? So when testing for pH value, the foods can be either acidic or basic. That's why sometimes you find that the food is sour, the food is bitter, the food is sweet, right? This is because they are either acidic or basic. Are we together? Now, other substances also besides food, they have these characteristics. Now we mentioned substances such as household substances, right? Our cleaning products, our soaps and so on, right? They also have these characteristics. They are either acidic or basic as well. Are we together? So now, as I've said, that chemicals may be classed or classified as acids and bases, right? Also, they are neutral substances, right? Substances that are not acidic and not basic at the same time, right? Which are just there in the middle, and we say such substances are neutral. So now what do we use to measure all of this level of acidity and alkalinity, right? pH, right? And specifically the pH scale, right? So the pH is the one that measures the levels of acidity and alkalinity in a solution, right? It measures how acidic or basic a solution is. Are we together? So now let's just remind each other some of the properties of acids before we continue. Right, we said that acids, they often taste sour, right? They taste sour, they feel rough, they have a pH value of less than 7, right? And also strong acids have the ability to burn our skin and eyes, right? Not only that, strong acids can also dissolve metals, right? They can eat away at metals, they are corrosive, right? So to mention some of the acids, we have lemon juice as an acid, vinegar as an acid, then we have carboxylic acid, which is made up of sulfuric acid, right? And that one is dangerous. It is the one that can peel off our skins, can burn our skins and eyes as well. Right. So now, if you look at most acidic substances, right, they have signs like this to indicate what? That there is an acid or this substance is an acid, right? And that you should be careful and use gloves when in contact with that certain substance. Right. Now, properties of bases, right? Bases are opposites of what? Of acids. But also now bases, one of their qualities is that they taste bitter, sweetish, or salty. Are we together? But also now bases can be strong, right? They can be strong, and as well as they can burn our skin and eyes, right? They can be dangerous to us as well, right? So bases react more easily with protein than with metal, right? And they're often used for cleaning, right? Most of our cleaning detergents, they are bases. So to mention some examples of bases, we talk about what? Baking soda, soap, and drain cleaner, which is dangerous as well, right? So remember now our lesson objectives. We said that we're going to compare and contrast, right? Meaning we're going to look at the similarities and differences between acids and bases, right? So if you look at this, one common thing that they share, right? Strong bases and strong acids can burn our skin and eyes, right? They can be dangerous. They can both be dangerous, right? Then other differences, they include what? Acids tasting sour, bases tasting sweet, salty, and bitter. Are we together? And the examples also, they are different. Are we together? So here is some example of what? Other bases, right? Like milk of magnesia, thick bleach, and so on, right? So now, let's quickly look at activity 1 and test ourselves quickly before we carry on with this lesson further, right? So the first question says, do you think orange juice is a weak or strong acid? Give a reason for your answer, right? Number 2, name any other acids that we use in our homes. Then number 3, bases are found in cleaning agents such as bleach, right? Then 3A, do you think that bleach is a strong or a weak base? Give a reason for your answer. Then 3B, name any other example of a base. So also for this activity, I'm going to give you 5 minutes to copy down and complete this activity. After, when you are done, don't forget to send in your answers on our WhatsApp number, which is 079 578 2908. Let's meet again after the activity. Welcome back, grade 9s. I hope you enjoyed your activity, right? We are still waiting for those answers and comments or questions regarding this lesson, right? On our WhatsApp number, which is 079 right? So don't be afraid to send in those answers because we are more than willing to assist you, right? So now, we are going to mark together, right? So now let's remember what our questions. Number one was saying, do you think orange juice is a strong or a weak acid? And give a reason for your answer, right? Number two, name any other acids that we use in our homes, right? Then number three, bases are found in cleaning agents such as bleach, right? Then 3A, do you think bleach is a strong or a weak base? Give a reason for your answer, right? Then B, name any other examples of a base, right? So let's hop on quickly to our corrections. Now, number one, it is a weak acid, right? Orange juice is a weak acid because we can drink it, right? Because we can drink it and it's not harmful to our bodies. Then, number two, other examples of acids, right? So, amongst others, we have these ones, right? Lemon juice, vinegar, yogurt, tea, milk, and coffee, right? So, give yourself 2 ticks for 2 examples, right? Then, number three, 3A, we say that it is a strong base, right? Bleach is a strong base because also it can remove color and clean objects, right? It is a strong base that fights off dirt, right? Then we have B, examples of bases, right? So amongst others, we have mentioned these ones, right? Soap, washing powder, detergents, ammonium cream cleaner, right? So mark any two as well, right? So I'm going to give you now a quick minute to copy down corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now we've been talking about acids and bases, right? So we've mentioned some of the properties of acids, right? And we gave you examples of lemon juice, hydrochloric acid, and so on, right? And also examples of bases. We've said that bases they taste bitter, and some examples they include sodium hydroxide, our bleaches, and so on, right? So now there are neutral substances again, right? So some substances are not acidic or basic, and those ones we call them neutral substances, right? And for example, pure water, right? Pure water is an example of a neutral substance. It is right there at pH value 7. It is neither acidic nor basic. Are we together? Right. But now, in most cases, most substances, right, they are either acidic or basic, right? So they can be identified as either acidic or basic, right? So like the soil in our backyards, right? So our soil in our backyards can either be acidic or basic, right? And the different levels now in terms of acidity and alkalinity in the soil, right? They favor different plants as well. Are we together? So we have loose soil, which is acidic, right? And in most cases, acidic soil it favors what? Planting plants such as ferns, right? Ferns are needing what? Acidic soil to grow perfectly, right? And also we have clay soil, which is alkaline, or we say it is basic. Are we together? Clay soil also favors flowers like lavenders, for example, right? So the soil can be different, can be either acidic or basic as well, favoring different types of plantation. Now, let's talk more about this pH now, right? So now a special name is given to the acid or base characteristic that a substance has, right? And it is called pH, right? So now pH, let's unpack this pH, right? When talking about pH, if you unpack the abbreviation, it stands for potential hydrogen. Now, I think some of you are getting it now, right? The P stands for potential, the H stands for hydrogen, right? So hence the potential of a substance to attract hydrogen ions, right? So now in our first lesson of acids and bases, we talked about what? When a substance has more and more hydrogen, we say that it is acidic, right? So now we're talking about what? The potential hydrogen of a substance in this case, right? So how do we measure this pH, right? So we measure pH by using special strips of paper called litmus paper, right? So there's blue litmus paper and a red litmus paper. The blue litmus paper turns red when testing for a substance, right? When you dip it in a substance, it turns red when the substance is acidic, right? The same blue litmus paper, if you put it inside a solution that is of a base, it will remain blue, right? The red litmus paper, if you dip it in a solution and the solution is a base, it will turn into a blue color. And also the same red litmus paper, right? If you put it inside what? An acidic solution, it will remain red, right? So it's simple like that, right? Acidic solutions, they turn blue litmus paper red. Basic solutions, they turn red litmus paper blue. Are we together? That's how we measure the pH, right? So how does this work now, right? So the paper is treated with chemicals that change color to show the range of pH, right? So when the paper touches the substance being tested, it turns a specific color to tell if the substance is an acid or a base, right? As I've said also in the previous slide, right? Blue litmus paper turns red when the solution is acidic. Red litmus paper turns blue when the solution is basic, right? So also we have a universal indicator paper. That one now is green in color, right? It starts off as neutral, right? Green in color, and it gives us all this range of colors also determined by what? By the level of acidity in that solution, right? If it's a weak acid, to give us this shade of green, right? Up until almost yellow, right? Or if it is a weak base, it will give us this shade of blue all the way to 11, right? To indicate the different levels of acidity and alkalinity. Right. So here now we have a pH scale, right? This pH scale ranges from 0 to 14, right? Indicating the different levels of acidity and alkalinity, where we have 7 as our neutral substances, right? So now, in this region, this is where we are going to find our strong acids, right? This is where we're going to find our strong acids when testing for pH, right? And in this region is where we're going to find our strongest bases, right? And both these strong acids and strong bases are the ones that are regarded as dangerous, right? Also now, we around 5 and 6 of pH value, we find weak acids, right? Then along pH value 8 and 9, that's where we find our weak bases, right? So also as we move on with this, look at the color codes here, right? Look at the colors that are indicated by the universal indicator, right? So just to mention some examples of these strong acids, strong bases, weak acids, and weak bases, right? For strong bases, we have strong acids, we have acids such as the hydrochloric acid, right? Or the gastric juice in our stomachs altogether. Then for our strong bases, we have our sodium hydroxide, right? Our bleach, right? Also, we have our weak acids along 5 and 6, which can be our tea that we can drink, right? It is not a strong acid because we are able to drink it. Also, on weak bases, we find substances such as eggs, right? That we are able to eat, right? We are able to eat eggs and they taste bitter as well. Right. So a universal indicator, as I've said, it has the ability to indicate the full range of values on the pH scale by color changes, right? So now, as I've said that the pH scale ranges from 0 to 14, right? Indicating what? Different levels of acidity and alkalinity, right? So now, pH 7, now it's where we find our neutral substances that are neither acidic or basic. Are we together? So pure water, for example, is pH 7, right? So now, low pH now, when talking about low pH, we're talking about acids, right? These now are found from 0 all the way to 6.9 of pH value, right? Because 7 is our neutral. So just below 7 at 6.9, it's where we find our acids going down to 0. So high pH value, we're talking about bases, right? And we start finding bases from pH value 7.1 and all the way to 14, right? So now, the closer to the ends of the scale, the stronger the solution is. So if you have 0, 7, and 14 on your pH scale, right? So this is where we're going to find what? Strong acids, right? Strong acids, and this is where we're going to find strong what? Bases. Are we together? Strong acids at the end or at the beginning of the pH scale, then strong bases at the end of the pH scale, right there at pH value 14. Right. So talking about acids, right, in terms of the pH scale. So we said that any substance with a pH value of less than 7 is considered to be an acid, right? So here is our pH scale again, right? All the way below 7 going that side, that's where we find our acids. Are we together? That's where we find our acids. Then right there at 7 is neutral substances. At 14 it is bases, right? Or strongest bases. Now, the Rhodes solution after adding a few drops of universal indicator indicates a strong acid with a pH value of less than 3, right? So as I've said that less than 3 here, it's where you find what? The strongest acids that are considered to be dangerous as well, right? So orange or yellow solution after adding a few drops of universal indicator, they indicate a weak acid with a pH value of between 3 and 6. So looking at bases now, a base is any substance with a pH value greater than 7, right? That is more than 7, right? So looking at an example of our pH scale here, right? The blue side here indicates all our bases, right? Or all our levels of alkalinity, right? We have 7 again, I emphasize, 7 is neutral. Below 7, that's where we start finding what? Our acids. Are we together? So now the blue solution, after adding a few drops of universal indicator, it indicates a weak base, right? With a pH value of between 8 to 11, right? Those are weak bases. But now, indigo or violet solution, after adding a few drops of in the universal indicator, it indicates what? A strong base, right? It indicates a strong base with the color indigo or violet, and it has a pH value of greater than 11, right? More than 11. From 11 going forward all the way to 14, that's where we find what our strong bases. Now, pH 7, right? pH 7, we say that they are neutral substances. They are not acidic and also they are not basic, right? Not acidic nor basic as well, right? So this is where we find our neutral substances. And therefore, we find no color change after adding a few drops of universal indicator, and the pH value is 7. Now, how can we use this pH paper or our litmus paper, right? These are the tips. Firstly, we do what? We place the edge of the litmus paper into the mixture, right? We place the edge of the litmus paper into the solution. Are we together? So after that, we observe the color change of the litmus paper. Are we together? Now also we match what? We match the resulting color to the colors listed on the outside of the litmus paper package. So also the colors match with a correlated pH number to tell us what? The levels of acidity or levels of alkalinity were on our solution, right? So the number is the pH value of the sample. Right. So we said that this is emphasis, right? So that it drills in our minds, right? We said that if the pH number is less than 7, then the substance is acidic, right? But if the pH number is more than 7, the substance is basic, right? So looking at what? This pH scale as well. Right there at 7, we find our neutral substances, right? Then from 7 going all the way to the right hand side, you find pH value 8, right? That would be the weakest base, right? From 8 moving on to 9, you find now what? A base which starts to be stronger than 8, right? All the way to 10. At 10, you find a base that is stronger than the one on pH value 9. At 11, that's where you find now the strong base, right? More than all the others, right? More than 10, 8, 9, and 8, right? Then at 12, you find also another strong base, which is stronger than the one at 11, 10, 9, 8. At 13 also, you find a base that is stronger than what? Than the one at 12, 11, 10, 9, and 8. Then also at 14, that's where you find our strongest base, right? Our strongest base. Right, we're going to start here at pH value 7 again, right? So moving down with the numbers now. pH value 7 going at 6, right? That's where we find now what? Our weak acids. Then moving on to pH value 5, we start to find now an acid that is quite stronger than the one at pH value 6, right? Moving on to pH value 4, we start to find now an acid that is stronger than the one at 5 and the one at 6. Are we together? Then at pH value 3, right, you find the strong acid again, right, which is stronger than the one at 3, 4, that is stronger than 4, 5, and 6. Then at pH value 2, you start to find one of the strongest acids again, right, which is stronger than the one at 3, 4, 5, and 6, right? At 1 and 0, that's where you find the most strong, what? Strongest acids, right? That's where you find the strongest acids that are stronger than the ones at 2, 3, 4, and 5, and 6 as well, of what? Of pH value. Right, now we have activity 2, right? We're going to explore activity 2 and mark together again, right? So now it says match the descriptions in column A with the correct words in column B, right? So in column A, you have descriptions such as a substance with a pH higher than 7, a measure of how acidic or basic a substance is, a strong acid, a substance with a pH less than 7, has the ability to indicate a full range of pH values by color change. Then 3, it's green in universal indicator. 7, it is red in a neutral substance. 8, it is a weak acid. Then 9, a substance that changes color in an acid and base, right? Then in column B, you have options such as acid, base, pH indicator, pH 7, red litmus paper, hydrochloric acid, vinegar, and universal indicator. So please match column A and B, and I'm going to give you 5 minutes to complete this activity. Then afterwards, we're going to mark together. Welcome back again, grade 9s. Now let's look at the solutions together. Match the descriptions in column A with the correct words in column B, right? Then number 1, a substance with a pH value higher than 7. What is the answer then? The answer is B, right? The answer is B. And what is B? B is a base, right? So it is correct to say that it is a substance with a pH higher than 7. Then number 2, a measure of how acidic or basic a substance is, right? And the answer is what? C, right? The answer is C. And the answer is C and pH, right? pH is a measure of how acidic or basic a substance is. Then number 3, a strong acid, right? The answer is G, right? What is G? G is hydrochloric acid, right? Is a strong acid. Then number 4, a substance with a pH less than 7. The answer is A, right? The answer is A. A is acid, right? And acid is a substance with a pH less than 7. Number 5, it has the ability to indicate a full range of pH values by color change, right? And the answer for that one is I, right? It is I. And I is what? Universal indicator. Right. Number 6, green in universal indicator, right? The answer is what? E, right? pH 7. So remember, I even circled the examples there to show that when using a universal indicator, a neutral substance that starts off as green, right? Then you start having different shades of green to blue or brighter colors such as yellow as you move from neutral to bases or neutral to acids, right? So the answer is E, which is pH 7. Then number 7, red in a neutral substance, right? That is what? That is F, right? F is what? It is red litmus paper. It does not change in a neutral substance. It remains red. Then 8, weak acid, right? Weak acid. And the answer is what? H, right? And H is vinegar, right? So vinegar is a weak acid. Then the last one, a substance that changes color in acid and base, right? What is that one? That is an indicator, which is D, right? So please mark your work, and I'm going to give you now 2 minutes to copy down corrections. And when we come back, we're going to summarize what we have learned for today. Welcome back again, grade 9s. Now let's summarize what we have learned for today, right? So today we're talking about the concept of the pH value, right? And we said that it is a special, the pH is a special name that is given to the acid or base characteristic and that a substance has, right? So we said that pH stands for potential hydrogen. Are we together? It stands for potential hydrogen, right? And we said that we measure pH by using litmus paper and universal indicator to indicate the full range of values on the pH scale by color changes, right? So this is how we use the litmus paper. We place the edge of the litmus paper into the mixture. We observe the color change of the litmus paper. Then we match the resulting color to the colors listed on the outside of the pH paper package. We also the colors match with a correlated what pH number, and tells us what the levels of acidity or alkalinity in that substance, right? And we say that the number is the pH value of the sample. So in the next lesson, we'll be talking more now about the reactions of acids and bases, right? So we'll be talking more specifically about neutralization, because we said that acids and bases have the abilities to neutralize each other, right? So we'll be talking about neutralization and pH altogether. So from me to you now, I hope you have enjoyed today's lesson. Thank you and goodbye.